So this section we're using trig to solve. So right now we want to know what's the area of triangle ABC if theta, that's our angle, is 21 degrees, A is 27, and B is 32. Alright, so first off, area of a triangle is 1/2 times the base times the height. So what we're missing here is H. And with H, we create a right triangle. Right? That is our trig part. So we have 21, we have 27, and we need to know X, or H. We need to know the height. I didn't include the 32 because that goes all the way across. Okay, so to solve a trig function, you only need two sides, one unknown and one known. And using our angle, that's going to tell us what trig function to use. So we don't know the opposite side, but we do know the hypotenuse. So you have to think which trig function uses opposite and hypotenuse. Sine, OH. Sine of theta is opposite over hypotenuse. Okay, so let's set up our equation. Sine of theta, theta's the angle, that's 21, equals opposite x over hypotenuse, 27. So now we're going to solve for x. So to get rid of a fraction, you always multiply by the denominator. And what that does is it creates x over 1, or just x. And 27 times sine of 21 is equal to x. So let's find out what that is. 27 times sine of 21 is 9.68 rounded. Guess what? That's our height. That's our x value. Now we can find our area. Area is 1/2 times the base all the way across, that's where we use our 32, times the height, which is what we just found, 9.68. So we're going to type that in our calculator and round to 2 decimal places. 1/2 times 32 times, I'm going to use the answer function. That means our last answer. So 154.81. Let's look at our next one. Suppose a Boy Scout uses his compass to take a 51-degree shortcut between two perpendicular trails, represented by Y to Z and X to Y. So perpendicular means creating a 90-degree angle. So that's the perpendicular part. If after leaving trail YZ, the scout reaches trail XY, 18 meters from the intersection of these trails, calculate the distance the scout walks between the two trails. All right, so let's go fill in what we know. He takes a 51-degree shortcut between the trails. That's this. And then the scout reached trail XY 18 meters from the intersection. Calculate the distance the scout walks. So that's from here to here. Calculate XZ. So A is 18. Oh, theta is 51. It tells us down there. I should have just kept reading. Okay, so here I have theta. Across from theta is the opposite side. Across from the right angle is the hypotenuse side. So this is what I know. This is what I'm trying to find out. So that tells me which, am I going to use sine, cosine, or tangent? I'm going to use sine because I know the opposite and I need the hypotenuse. I know nothing about the adjacent. I'm not going to use cosine or tangent. So now let's fill in. Theta is the angle, that's 51. Opposite is 18. Hypotenuse is x. Okay, I have an equation. First step, multiply by the denominator to get rid of the fraction. They go away. So now I have x times sine of 51 equals 18. All right, x is still not by itself. So we're going to divide both sides by sine of 51. Oops, I didn't need that parenthesis right there. So x equals 18 divided by sine of 51. We're going to put that in our calculator, and that's our answer. That's x to z. So 18 divided by sine of 51. 23.16. That's x. If a 30-yard sidewalk is slanted 64 degrees from the vertical, calculate the vertical change between the two ends of the sidewalk. I'm going to read this time and go c equals 30 and theta 64. What are we trying to find? Well, this time it doesn't tell us. So, a 30-yard sidewalk, here's the sidewalk. It's slanted 64 degrees from the vertical. Calculate the vertical change. All right, that's that. So let's see what we got. We know the hypotenuse. We do not know the opposite, so we're not going to use that one. We're trying to find the adjacent. So think sine, cosine, tangent. Which one has A and H? That's the one we use, okay? So cosine of theta is adjacent over hypotenuse. Well, the angle is 64. The adjacent is what we don't know, and hypotenuse is 30. What that does is it gives us an equation to solve. So multiply both sides by the denominator. Woohoo! X is by itself. So we just put it right in the calculator. We calculate it. 30 times sine, not sine, cosine of 64. I'm so used to sine. 13.15. That's x. So this one's the same question. We just have different angles. So this time we have 23, our theta is 78, and we're trying to find x. So again, it's cosine of the angle because we were trying to find the adjacent and we know the hypotenuse. So times both sides by the denominator. X is by itself, so we just calculate straight across. 23 times cosine of 78. 4.78. So look for questions that are the same like that, because we don't need to redo it all again. We already know we're using cosine. Okay, so we've already done one like this too. We used sine. So we're going to use sine again. Okay, so now here's our right triangle. Our base is 31 and our angle is 18. So here's our right triangle, 18. We know 28, we're trying to find this. So opposite over hypotenuse. Sine of 18 equals x over 28. Times by the denominator on both sides. I love when it's all like that and x is by itself already. Then we just calculate. 28 times sine of 18 is 8.65. So this is 8.65. To find the area of the whole triangle, though, we take 1/2 times the base times the height. So 1/2 times the base times my last answer. 134.11. So it goes pretty quick when you get the similar problems, okay? Again, we've done one like this. We know that we're going to use cosine. That's 80 degrees, that's 23, and we're trying to find the adjacent. So cosine of 80 equals x over 23 times both sides by 23. That gets x by itself, and then this goes in your calculator. 23 times cosine of 80, 3.9.